have with us today Victoria and Sergio Joshua from the Austrian Institute of Technology and REHUB Forge. They will together take us through their latest hackathon's results. It's good to see you guys. How are you doing?
Great.
Yes, we're excited.
All right, I'll let you go then.
Great. So hi, everyone. Very happy to be here. Speckle forever. Let's do it.
Yes, so welcome to the results of our internal hackathon, or almost a marathon, I would say. We did using a lot of Speckle, dubbed the New European Bauhaus and Computational Design, a Speckathonian approach. And let's start with the team.
Yeah, so we are 4 active researchers who participated, computational designers. You can see Josha, Andre, Egor from REHUB Forge, and myself, Vicky from AIT. Yeah, so we did both hackathons together, and today we will present to you the second one.
Yeah, as a background, we come from 2 companies. I'm and Igor, we are from REHUB Forge, the tagline Connecting Architectural Intelligence. We are quite young startup funded in 2020, based in Cologne, but with a lot of remote workers, with 40 architects and planners and 20 software engineers and computational designers. So this is quite a big team for the size of the company.
Yes, AIT, on the other hand, is a larger research and technology organization based in Austria and is primarily dedicated to advanced decarbonization through innovative technological solutions.
Big as a context, in the beginning of the year, we came together in this constellation, this team, for the first time for a hackathon for the conclusion of the Codec research project in Vienna. And there it was all about connecting kind of the traditional parts you would do in the urban design and planning project, from massing to simulation, analysis, visualization, and then KPI-based analysis. So we had a live demo prepared with a rather linear set of flows, where in the end Speckle really helped us to manage, deliver that in the live performance. And this year we want to take that a bit further.
Yes, exactly. So in contrast to the previous one, our second hackathon is aiming to disrupt this so-called linearity in the workflow. And to do that, we use Speckle, which really enabled us to input from various stakeholders using various software at various times, different input. The goal here was to expand this workflow with 30 new components, which you can see around this diagram, and also to facilitate their interconnectivity, breaking these constraints of time and space. Okay, we have also a vision here to create a more inclusive planning process, which aligns with the new European Bauhaus with its keywords, beautiful, sustainable, and together.
Yes, so now we would like to present the outcome in a video, actually, where we packed all of the results and brainstorming and prototyping into a narrative, which makes it easier to follow. And also the narrative itself is an outcome of this hackathon. The last hackathon we did as this team marked the conclusion of the Codec research project in Vienna. It was all about connecting the dots, integrating generative models with simulation, with visualization.
In the end, Speckle was a real lifesaver for us, enabling our tech demo to run smoothly and without problems.
Now this time around, we want to take this concept a bit further, focusing on the idea of connectivity, of building an extendable data space.
So the goal of this hackathon was actually start to connect not just tools, but also different people who work differently, who brainstorm differently around the topic of spatial design. We came up with different modules, which you could assemble or curate as a new workflow. But these modules actually can act in a physical, digital, augmented, virtual, collaborative, or solo environment.
And this aligns quite nice with the idea of the new European Bauhaus initiative.
It emphasizes the role of participation, collaboration, design, and happiness. We pondered a lot about how to bring the values of the new Bauhaus initiative into our project.
Now, next to this overarching concept, we targeted 3 tactical objectives and tangible objectives. Firstly, we aimed to make data both accessible and extendable. With complex projects, particularly those with numerous Speckle streams and branches, it can be quite challenging to track origins, updates, and the latest version. And our idea was here to create a web app that not only visualizes the connections between different Speckle streams,
but also maps the transformations happening to those streams and objects.
We really challenge ourselves how we can navigate these very complex landscapes of data and dialogues and feedback.
To illustrate this, we developed 2 examples. One was a user-friendly web augmented reality app to gather feedback from people within the neighborhood itself.
When it comes to the tangible interface part or tangible interface module, we found it quite important to extend the interaction of our tools with people who might not even want to touch a mouse, a keyboard, or any digital gadgets.
The final piece of this hackathon was to develop some interfaces leveraging large language models to navigate through the maze of user feedback and comments.
We experienced like an overload of tools trying to talk to each other, trying to have some kind of a dialogue and feedback. This is something very challenging. We yet find it very exciting.
Now, let's envision how this could play out in practice. We will use a hypothetical case of Aspen-Bechstein. Let's turn our attention to a hypothetical planning scenario in Vienna's Aspern-Seestadt, where we are about to embark on new construction plans. The starting point? Engaging workshops with planners and experts to brainstorm diverse parceling strategies. Urban planning is a multifaceted challenge, teeming with varied interests and requirements. A physical model brings these elements to life, facilitating a collaborative environment and discussion. Imagine this. Individuals interact with paper cutouts. The camera captures the arrangement, and these images are translated into the living digital language of our Speckle stream, where the automated scripts shape them into virtual parcels. On top, we're even integrating an automated building volume generation from REHUB Forge's generative design engine. To refine our approach, we apply additional scripts to project the implications of our designs on the microclimate, which, for instance, together with the shape of plots, impact pedestrian flows that we simulate too. Here, we employ data-driven design to guide our decisions collaboratively, all plugged in and connected via Speckle streams.
Advancing into the day, an experienced architect reviews the workshop's outcomes, refining the generative designs, factoring in regulation and safety using the volume generator. The outcomes are fed back to our live Speckle stream, enriching the preliminary work with expert precision. The complexity of cities demands multifaceted analysis. We can overlay additional analytical strata on our project, such as pedestrian flows, walkability, and nuanced microclimate simulations. The insights from these analyses are channeled into additional Speckle streams, accessible to all involved in the planning process.
Now, it's a good time to come back together and review what we have. A lab like this serves as an ideal interface to our project database, which grew to an almost challenging complexity. Our Speckle Stream project viewer, a prototype born from the hackathon, provides a panoramic view of all project data and methodologies, illustrated as an interactive graph. It's a tool that simplifies navigation through landscapes of streams and data layers from design variants analysis results. Moreover, the hardware screens devices offer the base for developing a rich set of tools for visualizing, analyzing, and filtering information. Dashboards allow us to go deeper. We can apply advanced analytical models and filtering methods, such as language-based querying, eventually assisting to create a short list of design based on KPIs for further developing.
With a pre-curated selection of designs, the question on more details gains relevancy. We might review facades, roof structures, and their influence on shading and solar potential. But how would it actually look like? Do we contribute to an aesthetic and spatial quality sufficiently? Once more, we utilize tools of REHUB Forge to align the roof generation module to our growing database. With the power of multimodal LLMs, we can initially populate the design space by language, reference images, or simply by saying make it look like the context. This generates a set of parameters taking spatial features into account, a perfect basis to continue manually. For diving deeper into facade details, complementing this with engines like Unity or Unreal, we gain a realistic sense of the space's future atmosphere. And also for the developers, questions of capacity and functionality are paramount. We constantly track GFA and other metrics, and for more detailed estimates of units. Here, the floor plan generator from REHUB provides quick estimates on potential living units.
As our project evolves, so does the public engagement. Imagine a public version of our Speckle Stream project viewer, shining a spotlight on data streams open for community input. Enter David, a local resident and developer intrigued by the ongoing project. Struggling to visualize the proposed changes, he discovers the project platform and puts together a WebXR app within 2 days. To experience the designs in augmented reality and channel his opinion back to the planning. With a simple button press, he captures his viewpoint, annotates it with his feedback, processed through ChatGPT and visualized via StableDiffusion, and reintegrates it into the Speckle Stream. This is citizen engagement in real time, shaping the communal space. Fast forward, and we find Vicky orchestrating a workshop with locals, exploring and discussing over the shortlisted designs.
Using tactile interfaces that sync with Speckle, participants' input becomes a part of the data fabric. Linked to Unreal Engine, these abstract object placements transform into high-quality 3D renditions. It's about demystifying urban planning, making it accessible and immersive for non-experts to contribute meaningfully. And as always, we can swiftly incorporate additional simulations like microclimate modeling to ensure well-informed feedback is captured alongside the geometric data.
This approach to digital twinning displays a vast potential of planning databases, fostering innovative inputs. The City Intelligence Lab is a nexus where data layers converge and stakeholders engage in dialogue. Leveraging large language models, we are refining how we synthesize feedback, semantically and spatially, into heat maps that pinpoint community focal points. This integrated process is more than a nod to technology. It embodies community sustainability and the new European Bauhaus initiative's vision for vibrant, inclusive living spaces. Yes, thanks for watching. So I think we have shown quite a lot of things and concept how to connect them and think them together. Since it was a hackathon, we actually implemented quite a few of these things to some degree, and would like to highlight some technical details on 4 selected one right now.
To start with the tangible to virtual, which we showed also in this participational workshops. So this workflow diagram is used mostly for public space design with citizens, and it is divided into 2 main parts. The first part on the left shows the capturing of physical objects with a camera, simple camera, anyone can do it, which then we digitize and calibrate using Python, and we stream them to Speckle, where we can take the data to Rhino and then calibrate these text or CSV files to generate KPI. So this would be the first part, but in order to connect that element, these physical elements, to realistic virtual images, we also convert the simple outlines from Rhino into Unity to very complex assets. This again is used with the Speckle connectors, and we owe a giant thank you to Jed. Thank you, Jed from Speckle, because he helped us a lot in implementing this method.
Yeah. Next, we experimented with driving parametric models with large language models. We took the roof generation script and rather successfully used GPT and GPT Vision now to derive the parameters for us. And this was actually worked quite well. We implemented this example completely in Grasshopper for up to 32 roofs, but the API results are still a bit inconsistent. So there's still quite some fine tuning to do.
Yeah, the third one is Community AR. You could see some parts in the video, which is a user-friendly web application revolutionizing collaborative design, we believe. So this tool allows anyone literally to open the Speckle components or Speckle streams on their phone and comment directly on parts of the 3D model. This would create a dynamic image from their voice input using StableDiffusion models and instantly integrate it into the model also. These contributions are then seamlessly fed back to Speckle, enrich the overall project.
And finally, we have the so-called Speckle project visualizer. That's something I actually really started using in real project, where we essentially have a webhook Python server on Hugging Face, quite simple to set up, that gets triggered when commits or branches get updated, and it writes a few metadata things in a Notion database in our case, and then that feeds a bouquet web app. That's kind of this dashboard here. We have also created snippets, Python snippets and Grasshopper snippets for code, for programs, so they also write in the metadata what streams they take in and what they spit out, so to say. So we have a complete graph with Speckle streams in blue and functions, Python and Grasshopper functions in yellow. And yeah, that were 4 things we wanted to highlight here. There are quite a few more things. The time is not enough to cover right now. And I think Vicky has some closing words.
We just want to say thank you to Speckle and to all the Speckle workers, because they really helped us on this way. We really enjoy generating complexity and craziness and doing overwhelming stuff. We are also very happy that Automate is released, and we will be the first ones on the list to try and maybe even link it back to all our ideas if you allow us to do so. But anyways, we somehow feel that the complexities all these things create is the next challenge, how to handle, how to navigate. And so Speckle Hackathon number 3 is coming soon.
Yeah, I think that will be all about managing the data. Thank you.
Well done, guys. Super impressive work, and very happy to hear all the positive feedback. Thank you so much for the presentation. We can't wait to see Hackathon number 3.
Thank you.
All right. See you soon. Bye.
Bye.
Bye-bye.